Tyler Cook, service engineer with Timken. Today we're at Jones Manufacturing in Beamer, Nebraska. We're going to install a Timken SAF 22522 on a Mighty Giant hammer mill. First things first, we need to make sure we've got our safety gear. It's going to be involved for this job. It's going to be gloves, steel-toed boots, safety glasses, and any other safety gear required by your company. To start off, we'll identify some of our tools that we're going to have. We're going to need a hammer, we're going to need a spanner wrench, we're going to need some feeler gauges, and then probably a socket and ratchet or end wrenches, whatever you prefer, to tighten down our housing bolts. So we're going to have our housing. We've already got everything unpackaged here. As you can see, we've made a mark on this housing to make sure that when we take it apart, we are going to get it oriented correctly coming back together. We've got our stabilizing ring here. That's going to make this our fixed bearing. We've got a set of seals that have already been pre-greased and ready to install. And then we've got the adapter, which consists of the sleeve, the lock washer, and the lock nut. So before we go to put this on, we need to make sure that we've got our shaft is in proper condition. So this unit is a 3 15/16, so 3.9375 inches. The tolerance for this particular unit is going to be +0, -0.004 of an inch. And that's going to put our range at 3.9375 inches all the way down to 3.9335 inches. We've already measured this shaft and it is within specification. Next, we need to know what bearing that we are going to be installing. This one right here is going to be a 22222 KEJ W33C3. So we need to break down that part number, and 222 is what the series is. The next set of twos there is actually one of them that we're really interested in because that tells us our bore size. K tells me that it's a tapered adapter. EJ tells me it's a stamped steel cage. W33 tells me it has a lubrication groove, and C3 is the clearance of this unit. So like I said, our second set of twos here is what we're interested in. That's 22 times 5 millimeters. It means that we have 110 millimeter bore diameter of this bearing going onto the tapered shaft. So 110 millimeter bore. Our C3 is our clearance, and we're going to see that on our card. I'm going to go ahead and unbox this bearing. We should always leave our bearings in the packaging and protected before we are ready to install. All right. So the next thing here, we're going to get out our spherical roller bearing installation card. We've identified that this is a 110 millimeter bore. So on the card, we're going to first come down here in nominal bearing bore. We are over 100 millimeters, and we are this chart says including 120. So if this was 120, we would still use this before moving down to the next line. We're 110, so we're going to use this line. C3, we can see a couple different locations here. We've got a couple different C3s on this card. That's what clearance section we're going to use. So this bearing, radial internal clearance prior to mounting for a C3 unit, is going to be 0.0067 inches as the maximum, 0.0053 inches as the minimum. Then we are going to reduce that as we push it up the tapered adapter sleeve, and we're going to reduce that by 0.0028 to 0.0020, and we will talk more about that in a second, the math that goes along with that. The minimum, so the minimum that we're going to come down to for a C3 is going to be 2.5 thousandths of clearance. So we're going to start at 0.0067 to 0.0053, and the minimum when we get done is going to be above 0.0025. One other thing, or two other things I highlighted on this is we've got a 1 to 12 taper unit, and the axial displacement, the tapered shaft installation, we're going to push this up the tapered adapter 0.042 inches a minimum of 0.030 inches. And then if we look down at the bottom, we can say for sleeve mounting, which we are doing, we're going to multiply those values by 1.1 for the 1 to 12 taper that we're using. That is going to give us a ballpark of how far we need to turn that nut in order to get this into our proper setting range. So just to reiterate, our new bearing is going to be 0.0053 to 0.0067. I've already pre-measured this bearing, and when we measure this, we're going to set it on the bench. We're going to oscillate our rollers, make sure everything is lined up, and then I'm going to take feeler gauges and I'm going to check, and I'm actually going to check both sides of this. And right there, my 7 is not fitting, but my 6 fits through there. I would measure the other side too. I've pre-measured this, and 6 thousandths is where we are at. So back to our sheet here, we've measured it at 6 thousandths clearance. That is within our specification of 0.0053 to 0.0067. Then we're going to do a little bit of math. We talked about removing some clearance from this. So 0.006 minus the smallest amount that we could remove was 2 thousandths. That comes out for 4 thousandths is what we would like to have. And then 0.0060 minus the maximum that we could remove is 0.0028. That gives us a value of 0.0032. So 0.0032 to 0.0040 is going to be our range we're looking for. Both of those numbers are above that minimum that we discussed there, 0.0025, so we are in good shape. Then we mentioned axial displacement. Just some ballpark calculations to get us in the range, 0.030 to 0.042. We're going to take both of those values times 1.1, as it stated on the bottom of the card, because we're using a sleeve. So that's going to come out, our range is going to be 0.0330 to 0.0462. And now what does that mean? We actually have our tapered adapter is going to be 12 threads per inch. So 1 inch equals 12 threads or 12 turns. We divide that out, and that tells us that for every turn that we turn that nut, it is 0.0833 inches. We can divide that out further. Kind of tells us that half a turn is 0.042, which is roughly in the middle of this range that we mentioned above. And if we actually divide that out further, and we look at our 19 tang lock washer that we have there, we're going to move this from our 0 point approximately 10.5 tangs for the maximum. So we will go ahead and get started installing this on the shaft. All right, we've gone ahead and put the inboard seal onto the shaft. We are now going to take the tapered adapter sleeve. We're going to slide that on roughly to where we want the center of that bearing to be. We're going to take a look at our bearing here, and we're going to make sure that we're putting this on in the proper orientation. So if you see on this side, this inner ring looks a little bit wider than it does on the other side. That's because there's a taper on this that's going to be running at an angle. So we need to make sure that we put the large end of the taper onto the adapter. So now I'm going to pick that up, and slide that on. We're going to grab our lock washer, put it on. We're going to take our lock nut, and we're going to get it on there loosely. And now we want to make sure that we get our bearing in the proper center location. For this one is actually going to be 5 3/4. So we're going to slide that back just a little bit and it's going to be 5 3/4 to the inside of that loop groove. Now we're going to go ahead and try to get started tightening up on this, and we're going to do hand tight on that lock washer, or on the lock nut, excuse me. Make sure that we keep our bearing lined up and get this as tight as we can get it by hand. Next, we're going to make a mark kind of where we're starting, and so we've marked our starting and finishing locations. As we said earlier, we're going to want to move this roughly half a turn, about 10.5 tanks. Now we're going to get our wrench. We're going to make one more double check to make sure that we are lined up where we wanted this. And now we will begin tightening. There. At this point, I'm actually going to take my feeler gauge, and we were aiming for between 3.2 and 4 thousandths of an inch. I'm going to check and see that we are within our proper range. And this unit is within, it is at 3 thousandths. So it's slightly under that, but it is still above our minimum. So at that point, we're going to go ahead and we're going to peen over this tang on the lock washer, and we'll move on to our next step. All right, we've gone ahead and we have double checked to make sure that our bearing was within the clearance that we were looking for. We have double checked and made sure that the center line of the bearing is in the right measured location. We've gone ahead and put our other outboard seal on now. And now we're going to go ahead and we're going to start greasing this unit. So we're going to use our electric grease gun here. And we are going to start putting a bead around this bearing. And we're going to get a good amount of grease on there, and we're actually going to push some of that inside of this unit because we want to get every surface on the inside of this covered so that we don't have a dry startup condition. So we'll just continue going around and forcing grease all the way into every open area of this unit. We're not going to go, we could measure this amount. We're not going to go to 100% full, but we're going to go somewhere in the area of 60%, and we will rotate this unit over a little bit to make sure everything gets packed inside and gets everything covered with grease so that we don't have a dry startup condition. All right, we've gone ahead and finished packing both rows of this bearing. We've rotated it a few times to ensure that we've got it pretty well full of grease. There's not going to be any dry areas of this bearing when it starts up. We have brought the housing in, and we have pulled this housing so that it is all the way out as far as it will go. On this is going to be our fixed unit, and so we've pressed it up against this shoulder in the housing to leave a space over here. Now we're going to go ahead and we're going to install our stabilizing ring. This is what makes this our fixed bearing unit. And And now that we've got that in there, we're going to go ahead and start greasing this unit. With this unit, because of the speed, we're going to fill this housing approximately 1/3 of the total capacity. That is top and bottom included. And then at that point, we'll be ready to put the cap on. So I'm going to go ahead and finish this up, and we'll be right back. All right, we've gone ahead and finished filling the housing approximately 1/3. You can see kind of where that is in the bottom side of this housing, a little less than that halfway mark. We've got our stabilizing ring in there good. And we're going to check and make sure we've got our match mark there. Now I'm going to grab the top side of this housing, bring it over, line it up with my match mark, push this down. I'm going to go ahead and put all of my bolts in, and I'm going to torque those to the proper specification. That's going to pull the entire housing together. And backward. And we're going to go ahead and we'll snug those up, and then we will torque these to proper specification, and we are done installing the Timken SAF 22522 on this mighty giant mill. Thanks.